So, you want to learn about Apache Maven? Well, you've come to the right place. Hi, I'm Cameron McKenzie. I'm the editor-in-chief over at theserverside.com, and I've put together an Apache Maven crash course. And if you stick with me for the next few minutes, I guarantee that you're going to become very dangerous when it comes to using this Apache build tool. In the next little while, I'm going to show you how to install Maven, build Java projects using Maven from scratch, compile code with Maven, run tests with Maven. I'm going to show you all about Apache's dependency management capabilities. I'm going to have you add dependencies, configure plugins, run jar files, use static code analysis tools. I'd like to bring an Apache Maven project into Eclipse so that we can actually use Apache inside of an IDE. And of course, if you're doing a build tool, you're probably interested in continuous integration, continuous delivery, and continuous deployment. And so I'd actually like to show you how Jenkins integrates with Maven as well. As I said, just give me a few minutes and I think you're going to learn a lot about Apache Maven. You know, people that come and watch my tutorials are usually pretty advanced users and they want me to jump right into the practical application of the tool. So I'm not going to go on too long about talking about what Apache Maven is, but I think I need to kind of discuss the topic just a little bit. Fundamentally, Apache Maven is a build tool. It allows you to compile Java code, run tests, package your applications into things like jar files, war files, and ear files. And it even allows you to take those resources and maybe push them up to an artifact repository. So fundamentally, Maven is a build tool, but Maven's more than just a build tool. I'd say that the biggest and best feature of Maven is its ability to do dependency management. So if you're working on a project and you need a third-party library, you can sometimes get into issues where your project ends up having one version of it somewhere on your class path and another version shows up, and then you have class path issues at runtime. You don't know which version to download. Maven does dependency management for you. It allows you to describe the dependencies your project has in a project object model. It organizes and downloads those resources for you, and it helps you avoid a lot of problems with managing dependencies in enterprise scale Java applications. The other thing that it does is it can connect to a central Maven repository. That's a place in the cloud where people have pushed their jar files so that if you need a third-party jar file, Maven can go out and grab that jar file for you. The benefit of that feature cannot be understated. But beyond that, I would say that one of the other great features about Maven is just the plugin framework that it provides. So third-party vendors can create products, they can create tools that plug right into Apache Maven. So if some vendor says, hey, you know, as soon as somebody writes some code, saves some code, compiles some code, we'd like to do a security analysis of that code, or we would like to look for bugs inside that code. Vendors can create plugins, and we're going to look at plugins in this tutorial. Vendors can create plugins that can integrate with Maven, so that as soon as you compile your code, it'll do a look at all of your code to see if there's any bugs in there, if there's any security flaws, if there's any performance bottlenecks. So the plugin framework that Apache Maven provides is also one of its compelling features. But, you know, that's enough about what Maven is. Let's get into the practical aspect of working with Maven. So if you want to use Maven, the first thing you're going to have to do is install Maven. And that may not even be the first thing you have to do, because before you install Maven, you have to install the JDK and put the JDK's bin directory on the path. Now, installing Java and the JDK isn't too hard. All you have to do is head over to adoptium.net. You see the link there for downloading the latest LTS long-term support release. Once that's downloaded, you'll see a little exe file on your file system, and it's just a matter of double-clicking and accepting all of the defaults. Now, I'm not going to accept all the defaults. I like to add the JDK to my path. And also, I would also say that, you know what, I don't like the default folder that the JDK gets put into. I never liked this program files folder. I'm just going to install into a folder called _tools. /JDK17, do what you want, install it wherever you want. But that's fundamentally it. Just get Java installed. That is the first step. Okay, and with Java installed, you're off to the second step, which is downloading Apache Maven, maven.apache.org. Follow the download link. I'm on Windows, so I'm going to download the Apache binary file there, just a zip file. I've already downloaded it. I'm just going to extract it with 7-zip right on my file system. So I'll do a little extract here. You see it creates that Apache Maven folder. I'm actually just going to change that to Maven. And I'm going to copy that folder. You can copy the folder anywhere. It's not a difficult installation. I'm going to copy it into _tools where I put all of my tools. And once it's there, I need to do two things. I need to configure Maven home. And I also need to put this bin directory on the path, because in that bin directory is this mvn command, this mvn file, and that is the bytecode embodiment of Maven right there. That's the command that we're going to call mvn inside that bin directory, bind directory, whatever you want to call that directory. So I got a couple of environment variables that I need to set. So I'm going to edit a couple of systems variables. Over here, I'm going to add a couple of system variables. The first one is M2 home. Now that one, you don't really need that one anymore, but some old systems like it. So I'm going to just do it. So C:_tools Maven. The one you really want to do is Maven home. And then once you've done that, you want to go find that path variable. And there it is right there. And there you can see our JDK got added to it. Now let's add some company there. We want the JDK and we want that Maven bind directory, that Maven bin directory where you put your binaries. Okay, so that is essentially the setup. Once that is done, it's just a matter of going in and, I don't know, I'm going to open up PowerShell here. Okay, I got PowerShell configured there. And what I'm going to do is I'm just going to run this mvn --version command. That's going to tell me if indeed mvn Maven, remember mvn is the name of the command that we use whenever we want to call on Maven. I want to see if mvn is right there, and boom, it is. So Maven has now been successfully installed. The next step is actually to start using this Maven tool. One of the things I forgot to mention earlier when I was talking about what Maven is was the fact that Maven is also a configuration tool. You can say to Maven, hey, I want you to create and configure a Java application for me, and it'll give you thousands of templates to select from, and it'll create the structure or skeleton of a Java project for you. That's what I want to do right now. I'm going to go into Maven and I'm going to say, hey, Maven, you know what I'd like? I'd like you to go into that long library of archetypes that you have, and I'd like you to generate a new Java project for me. Archetype is like a template of a type of Java application. I just want to have a simple basic application right now. By the way, if you actually clicked enter on that command, the internet might actually go down because there's like 1,000 different templates that it will offer you to select from. In fact, I think there's over 3,000. You can filter that down a little bit, which I suggest you do, but with the -d command, and say, let's filter that down just to the ones at org.apache.maven.archetypes. Put a colon in there and put a double quote at the end. And these archetype names are going to be pretty long. So I'm going to open up the PowerShell screen just a little bit. I'm also going to double check that. MVN, that's the Maven command. Archetypes, archetype, I almost got that wrong. It's archetype on the left, but it's archetypes on the right. Generate, defilter, org, Apache, Maven, archetypes. Okay, I'm confident. I'm going to click enter there. And it's going to come back and it's going to say to me, hey, sure, there's a bunch of different archetypes. In fact, Apache Maven is going to go down and connect to Maven Central and download all the information that it needs about creating archetypes. That's one of the cool things about Maven. Whenever it needs some information, it can go and connect to Apache Maven Central and grab all of the information that it needs. Now here it's come back to me and it said, what kind of project do you want to create? Here are a number of options. Do you want a simple J2EE application? Do you want to create a Maven plugin? Or maybe, number 9, do you want to create a Maven Java Quick Start project? And I'm going to select number 9. It's going to say, which version of that project do you want? It looks like the latest is number 8, so I'll click number 8. And it says, okay, fantastic, we'll create a new project for you, but we need some details. The first detail is the group ID. Every Maven project has to have a unique identifier to it. Most people use their domain name. So for me, that is com.mcnz, and then some sort of descriptor of the project. And I'll just call this Maven, not too creative. And that gives the group ID, a unique identifier of this project that you're creating. Then you need an artifact ID. And I will call this the Maven Crash Course artifact. Now, by the way, when you have Maven build your project and create a jar file or an ear file or a war file, it's that name that it uses to create the file. So a little later, we'll see a Maven Crash Course.jar file created. People often say, well, where does that name come from? And I say, hey, it comes from the artifact ID. Finally, you need a version. I'll just say 1.0. In fact, the jar file it creates will be maven-crash-course, Maven Crash Course -1.0.jar will be the name of the file that we'll see a little bit later. 1.0 is ambitious. You don't usually put in a full increment release to begin with, but I'm going to be ambitious. Then it asks for the package name, just where all the Java class files are going to go. And I'm just going to use the same as the group ID. That's standard. By the way, that combination there of group ID, artifact ID, and version is often referred to as the GAV. What's the Maven GAV? G-A-V, group ID, artifact ID, version. That is the GAV. Okay, I'm going to click enter. It's going to say, do you like this GAV? I'm going to say, I love that GAV. And we click enter. And boy, did anything happen? You bet yourself it did. I'm going to come over here and on the C drive, you'll notice that a new folder has been created, and that new folder that's been created is Maven Crash Course. And there it is right there. Okay, so I'm now going to dig into that folder, take a little bit of a look around here, and what do we see? Well, first of all, there's that source folder. SRC, some people call it. I've heard people call it sourcey. I don't know if that's right or wrong. There's the POM file. Now, the POM file is the heart of your Maven project. We're going to dig into that in a little while, but every Maven project has to have a POM file, pom.xml file in the root of the project. If it doesn't, it's not a Maven project. But let's go look into this SRC folder. There's a main and a test folder. Under main, we've got com.mcnz Maven, and look at that, a little file named app.java. And if I give it a hard double click, I can see all that beautiful code for a Hello World program presented to me. And if I go in here and I take a look in that test folder, what do you think I'll see? Well, I'll probably see a Java class file called app.test.java, and here we've got some code that will test the Hello World app.java class that we just saw in that main subfolder. So there you go. Maven has gone in, it's created a POM file, it's created the structure of a basic project for me. What can I do now? Well, one of the things I can do is I can go in. Here we are. Let's see if we can get Maven to, I don't know, compile this code. How would you do that? Well, the first thing you need to do is you need to move into that folder that's got the same name as the project. So I'm going to go cd maven star. That should get me in there. There's Maven Crash Course. If I do a little dir or ls, you can see the pom.xml file in there. And once I'm in there, I can say, hey, Maven, I want you to compile this code. Now, as that happens, I want you to keep your eye on that Maven crash course folder. Watch what happens as I ask Maven to compile this code. Boom, you can see that target folder get created, and that target folder has all of the compiled class files. So I said, hey Maven, can you compile? It actually goes out, it creates a Walmart folder, sorry, a target folder, and it puts all of the compiled classes right in there. So what can Maven do? Well, one thing it can do is compile your code. Now I see app.class there, I don't see app test. Well, there's an easy way to fix that. We can say, Maven, don't just compile the code, but run the tests. And now Maven's going to go out there. It's going to start compiling some code. It's going to take a look at that test class. It's going to run those tests. It's going to create a bit more code for me. You can actually see generated sources, generated test sources, Surefire reports, test classes as well. So that's all been put into this project now. So there's all the compiled test classes. And it also says test run 1, failures 0. So you can get Maven to go in and test your code. By the way, if you start getting annoyed by that target folder, you can always do a Maven clean. And Maven clean just goes in, finds that target folder and cleans it up a little bit for you. So you can see that target folder is deleted. Now, the next thing I'm going to do here is I'm going to go take a look at my code. That deletes the target folder, but it doesn't delete the source code, right? I'm going to go in here, take a look at apptest.java, and maybe I will remove a semicolon. Actually, I'm not going to remove a semicolon. I'm going to assert that true is false. So I'm not going to actually write bad code. I'm actually going to create a test that fails. So assert true, the term false. Now that is some serious third year, maybe even PhD level philosophy that's going on here. But let's see what happens after I save that file and I run my Maven test. What happens? I'm going to assert that true is false. It then looks at this metaphysically and says, you know what? That isn't right. You've got to actually fix that up. I've now got a test failure, and it says to me, you know what? What you said there just doesn't make sense. We ran a test and that test failed. So I can switch that back to true. The universe is just the way it should be. And then I can run that Maven test again and boom, all of a sudden it's successful. Now I did that missing semicolon thing. That's actually something I want to do. I just don't want to do it on one of the test classes. Let me just show you here. If you got some bad code and you do Maven compile, well, as you could imagine, Maven will tell you that, hey, that code doesn't compile. And they're even telling me, semicolon is expected. And I do what's expected of me, so I'm going to add that back and compile again. But take a look, just think, what have we done so far? Well, we've had Maven create a project based on an archetype. It's created code for us. We've gone in, it's created tests, we've run tests, we've compiled the code, we've made code fail, we have made tests fail. It's picked up on all of that every time we do a build, even can clean the environment to make things look handsome again. Now here's another cool thing that Maven can do, and I'm going to open up that Walmart folder, target folder, and I'm going to say, Maven, you know what? Our tests are passing, our code's compiling. Why don't you package this up as a jar file so that I can maybe deploy it somewhere? So I just do that Maven MVN package command, and boom, did you notice what just happened in that target folder? There's a new file called Maven Crash Course 1.0.jar. It just created a new jar file. And where did it get that name from? Oh, that's right, the gav, where we specified that the artifact name was going to be Maven Crash Course and the version was 1.0. So there you go. Maven can package your applications up for you as well. Now, a lot of times when people are building their applications, they actually just do a Maven install. You'll see a lot of developers on your team just do MVN install. And what is install? Well, there's actually a local Maven repository on your local file system. I'm going to dig into users, I'm going to dig into owner, I'm going to dig into M2, that's the Maven repository right there, and I'm going to dig even deeper and go into this COM folder, and you notice that there's some heavyweights in there. There's Google, there's IBM, there's ThoughtWorks. Where's MCNZ? Where am I? Well, I do have that jar file. If I actually say mvn install, what's going to happen is Maven is not only going to compile my code, test my code, package my code, but boom, you can see right there, it's actually going to install my jar file into the local Maven repository so that if I run any other projects on this workstation that might need that particular set of Java files, well, they're right there. They're now available for other projects. So that's what the mvn install command does. Now, by the way, I mentioned a lot of people, you'll just see them do mvn install. You won't see them do mvn compile, mvn package. That's because mvn install includes compile, test, and package. So it's sort of a one-stop fits all. So there you go. Those are the basic Maven commands that you can do. You can also do a mvn validate. Now, validate will just make sure that your Maven project complies with what Maven expects a project to look like. Of course, we just created this project using Maven 5 minutes ago, so I wouldn't expect to get any static here. But that just gives you one more feather in your cap, right? Just one more Maven command that we can say that we've learned. And what did we learn? Well, we learned how to generate a new project with Maven Archetype. We did a Maven compile, a Maven test, a Maven package, a Maven install, maybe even a Maven validate, and a Maven clean. And I think that's a pretty good overview of the basic Maven commands. But trust me, there's more to come. So far, we've seen some pretty cool features of Maven, but we haven't even seen its coolest feature yet, which is its ability to manage dependencies. Now, let's take a look at some JavaDoc here. This is some JavaDoc from a third-party library, Apache Commons utilities here, Apache Commons collections, and there's an interface called unmodifiable. And I'm just going to implement this interface. Let's just say that in my Maven code, I'd really like to declare that this code would be unmodifiable. So I'll open up that app.java file and just say implements unmodifiable, maybe even import. What do I have to import there? org.apache.commons.collections4.star, I believe, is what I need to import there. Now, when you're building an enterprise application, you're going to be using all sorts of third-party libraries, whether it's from Apache, whether it's from Red Hat, whether it's Hibernate, whatever. And you're constantly using these external libraries. Now, if I try to run my code right now, just do a Maven install, it's going to say, hey, I don't know what this Apache Commons Collection 4 junk is that you're giving me. I got no idea about this. Well, with Maven, all you have to do is edit your pom.xml file. And when you edit your pom.xml file, you just have to say, hey, there's a dependency that I have. I've got a dependency on Apache Commons collections. Hey, Maven, if that file isn't local, bring it down and make it available at compile time. And furthermore, if we need to actually package that jar file when we deploy our application, put it into the package jar file. And so here's how you do it. Well, as you can see, this is part of org.apache commons collections, interface unmodifiable. You head over to the Maven Central repository. I'm just going to go do a Google for it and find it. Here is the Maven repository. You can find all sorts of different projects here. Like if I wanted to type in Hibernate, I could go over here and there's Hibernate core. I could type in Spring. There's Spring Core, Spring Web, Spring Beans. And if I wanted to type in org.apache.commons, well, I'd see a whole bunch of different Apache Commons collections, projects that I could include in my project. Now the one that I need is this one here, Apache Commons Collections. And you can see if you open up the page, it says, well, what version do you want? 4, 4.1, 4.2, 4.3. I'll say, hey, I want 4.4, why not? And it'll actually give you this code here that you can copy. I'm just going to copy that code. And I can just put that code into a POM file under the listing of dependencies. And now the next time I run my program, Maven is actually going to reach out to the cloud, download the jar files that I need, make them available, and my code will compile and eventually run. And notice they also have directives for Gradle, for SBT, for Ivy, for Builder. Pretty cool stuff. But anyways, I'm going to use the one for actually Builder. Kind of impresses me, so I didn't think I'd see Builder there. So good for you guys running that project. Here I am. I've got my dependency. I'm going to open up the pom.xml file. That'll be right in the root of the project. And not too much here. Oh, look at that. Compiler settings, 1.7. I'm going to change that to 17. I don't have to right now, but just on a matter of principle, we should not be defaulting to Java 1.7. We can see the dependency for JUnit. That's how the test classes were able to work, because the POM that gets created already has a dependency on JUnit. And under dependencies, I'm going to just add mine in. There we go. I've got a dependency on org.apache commons, Commons Collections 4 specifically, version 4.4. Notice the GAV. I talked about the GAV right at the beginning, group ID, artifact ID, and version. That's how you uniquely identify a project in the Maven repository. You can see it right there. Now I'm going to click Control S to save that file. You got to save your POM. And then I'm going to open up Windows PowerShell once again. Click the up button to do the Maven install, and watch the magic that happens right here. You can see it saying, hey, we're downloading from Maven Central. We're downloading the org.commons.apache, whatever it is, whatever I said. And now the code compiles, right? So previously, before adding that dependency to my Maven POM file, the Java environment had no idea how to link to that org.apache.commons project. Now I just put a little dependency inside of my pom.xml file, and Maven takes care of the rest. Like, it really, really is a beautiful thing. And you know what? It even gets better. And one of the ways it gets better was the whole plugin framework, which we're going to talk about next. So I hope you're enjoying this journey into Maven. I hope you're starting to love the Maven build tool as much as I do. You know, there's a lot of cool things that Maven can do, but you know what its secret weapon is? Its secret weapon is its plug-in architecture. With Maven, any third-party vendor can create a plugin that you can trigger after a build, after a package, after you've run through your tests. And those third-party vendors could be doing things like providing you tools that do performance management, that look for bugs, that enforce coding styles. I mean, it can do literally anything as long as it's within the realm of programming it up using the Java APIs. And I want to show you how easy it is to incorporate a plugin into your code. Now, in the pom.xml file here, there's a little section for plugins. I'm going to paste in a reference to the Codehaus plugin, and this plugin will actually run your Java code, right? Maven can compile code, it can run tests, it can package your code, it can do that install into the M2 Maven repository, but it doesn't have anything that runs it. So there's a plugin that you can install, just reference it, the GAV, and a little configuration in your pom.xml file, point to the file of yours that has some code that you want to run. And of course, the file that's got our executable code is com.mcnz.maven.app. And if you don't believe me there, I can always go in and find that code. And there it is right there. And in fact, I'm going to do hello Maven world just to kind of shake things up a little bit. So I've installed the plugin. I've actually changed my code just a little bit. And then to use the plugin, all I have to do is say Maven install. It's what we normally do. And say exec::java. That actually calls the plugin. How do I know exec::java calls the plugin? Well, because I read the plugin's documentation. The documentation will tell you exactly how to invoke it. Now when I click enter, well, the whole Maven routine will run as normal, but if you keep a keen eye on the output, you'll notice that it says, boom, hello Maven world. So we've now installed a plugin. Maven's downloaded the code to support the plugin. It's run the plugin when we do an install, and we've got a hello Maven world. And that may only be running the code, but you can imagine that with the entire Java programming language and its ecosystem available to vendors, you can get some pretty amazing plugins. And in fact, when you're working with plugins, you don't even have to necessarily edit that pom.xml file. There's actually a way to invoke plugins right from the command line. I'm going to do a little trickery here. I'm going to declare a variable and never use it. That is a bad programming practice, okay? And it's a source of bugs too, right? If you have variables that aren't used, it can cause problems, maybe memory leaks, whatever. So it's just not a good idea. Now here's what I'm going to do. I'm going to make that edit to that code, and then I'm going to run this command, and I'm going to say mvn install. And not only do I want to run the Maven install, the compile, test, and package, but I also run the CheckStyle plugin and make sure that, well, the developers are complying with all of our coding style guidelines. And I want to see if there's any programmer mistakes in there. So I'll call on the Programmer Mistake Detection Tool, PMD. I don't know if that's what it really means, but that's what they say it means. But CheckStyle is a plugin that just does what you would expect it to do, checks the style of the code. PMD looks for bugs. I'm going to click enter here. This will run. You'll notice a couple of references to CheckStyle and PMD in the output. And then once I'm done, I can head over to that Walmart folder. And in the Target folder, and in the Target folder under Site, you'll see there's two new files, CheckStyle and PMD. If I take a look at CheckStyle, well, CheckStyle doesn't like my star import. It says that on line number 3, there's a star import. That's considered a bad practice. Now, was there a star import on line number 3? I'm going to go check that. Well, there we go. Line number 3, we've got the star import. Now, what else was there? I think I saw another couple of files there. So I'll dig in, take a look at that site folder. There was PMD, and it says, hey, there's an unused local variable on line 14, and you got to fix that because that is a common source of bugs in programs, and you shouldn't just leave that be. And so that is, so there you go. In just a couple of minutes, I've shown you 3 plugins: the Codehaus plugin, the PMD plugin, the CheckStyle plugin. There's a FindBugs: you can do as well. And all of those will pull code off of Maven Central and provide added functionality to your builds. And, you know, really, there's no reason why a developer shouldn't run FindBugs or CheckStyle every time they do a build, right? You want that feedback right away. Shift left. That's the whole idea of DevOps, right? Take those jobs that used to happen in the operations team and bring them closer to the development, closer to the code. And so there you go. That, as I said, is really Maven's secret weapon. Not just all the cool things that it does for us, but the fact that vendors, anybody, the open source community can write plugins that can do amazing things and help you write better code. We've avoided an IDE to this point in time because I know that a lot of my viewers, they're very technical and they like to work on the command line and they like to work on the file system. But, you know, if you're going to be doing enterprise software development, you need to be working in an IDE. One of my favorites is Eclipse, and Maven integrates really well with Eclipse. So what I want to do is I want to open up Eclipse right here, and I want to import in that project that we've been working on. And I want to decorate it with a few more Maven dependencies. And I'd actually like to turn it into a Spring Boot application and run it as a RESTful web service if you don't mind. And it really won't take me too long to do that with Maven on my side. Now you'll notice that one of the first links there is create a Maven project. I've already got a Maven project, so I'm just going to import my own. That's just a matter of going File, Import, then looking for the import existing Maven project into Eclipse. Then you just got to find the folder where your pom.xml file is. And for me, that was the Maven crash course folder. So I'll select that folder. It finds the pom.xml file and I click finish and the project gets built. We actually take a look and see if all of the different dependencies are satisfied. And all of a sudden I've got my Maven project over here inside of Eclipse. Now, by the way, when you import a project for the first time, sometimes it can't find all of the files that it's supposed to link to. So when you import a big project into Eclipse, it's not uncommon to have to right-click on it, say Maven and update project, and let Maven update all of the dependencies to make sure that all of the errors that might display on an import go away. But this is a pretty simple project. I should be okay, but just keep that in mind if you're importing a bigger project into Eclipse. Right-click Maven update project. That'll probably save you a lot of headaches in the future. Now, you did notice there's a bunch of different options there on that context menu. So look, Maven, add dependency, add plugin, update project. Those are all things, that we've worked with before, right? So a lot of the stuff that we've done in the command line, there are wizards that allow you to do it inside of the tool. Furthermore, if you right-click on a project and say Run As, you've got the option to do a Maven clean, a Maven install, a Maven and test. So I can even do a Maven install right now. That's not a bad thing to do when you import a project in. Just make sure everything gets built, everything gets compiled, and sometimes it can synchronize your IDE with the files and the file system and all the dependencies. And you can see I get a build success message here. So life is good. I can open up the pom.xml file and you'll see that the pom.xml file is displayed as XML. But this is a nice little tool that allows you to visually look at the POM. So you can see on the first tab, the overview tab, it's got the GAV, group ID, artifact ID version. Remember that, GAV. And then it's got a listing of the dependencies. On the second tab, you can see Apache Commons and JUnit. It's got a dependency hierarchy. Now, some of your dependencies may depend on other dependencies. And so you see JUnit, it depends on Hamcrest core. There's also something called the effective POM. That's kind of like if you took all of the different POM files that you depended on and put them all together, what would it look like? And you can see that, this is actually pretty long. And in the grand scheme of things, this actually isn't that long. Once we go and add things like Spring Boot in, it gets even longer. And that's what I wanted to do. If you're working on an enterprise project, you're probably going to be using frameworks that have a large number of dependencies. Spring Boot is one. There's a lot of different projects that Spring Boot requires. But there's a neat Maven annotation called parent. And you can put a parent annotation into a Maven POM file. You throw it right after the model version tag. And you can say, hey, this POM file is going to sort of inherit from this other POM file that's got a crazy number of links on it. And so here I've said, I want this project to bring in everything that the core Spring Boot framework makes available. So I've said, make the parent POM the POM from the org Spring Framework Boot project. And so that now makes a whole bunch of projects and dependencies available to me. This is importing in the Spring Framework. It's not uncommon for many corporations to have a set of projects that they use for logging and monitoring and common collections that they have you reference when you create a project as well as some sort of a parent file. So that's the parent. Now, that doesn't bring in everything. If I'm actually doing some development with Spring Boot, I always like to add a couple of dependencies. I do a lot of RESTful web development. In order to do RESTful web development with Spring Boot, you need the Spring Boot Starter web project. And of course, I like to test things from time to time, so I'm adding in the Spring Boot Starter test as well. But a couple of projects that you can add in there. Now, one other thing that you need when you're doing Spring Boot, especially if you're creating microservices and deploying microservices into Docker containers and pushing that into cloud-hosted services, is you need to take your web applications and package them up, put them into a server like Tomcat or Jetty or Undertow, and then put all of that in a single jar file that's executable and then deploy it. And that sounds like a lot of work, and it is, because I've done it from scratch before, but what do we have available to us that makes it possible for vendors to provide cool, extra added functionality to us? Well, vendors can add plugins. And the clever folks at Spring Boot have a plugin that makes it possible for us to take our Maven projects and package them in a jar file that's got a Tomcat server in them that can run our applications as RESTful web services and microservices. And all you have to do is put that little Spring Boot Maven plugin decoration into your POM file. Now, after you do that, you should always update your code. So I want to say source, not source, Maven, update project. That's just going to synchronize everything and also bring in all of that Spring goodness into my code. And believe it or not, I'm going to take like 3 minutes. What time is it now? I got 9 after the hour. I'm going to take just a couple minutes and create a RESTful web application in Spring Boot because it's really simple. The hardest part is just configuring Maven. So if you wanted to write a RESTful web service in Spring Boot, you would just, well, you do all the Maven stuff and then you say Spring Boot application. So you just say this is a Spring Boot application. You say it's going to be a REST controller too. It's not a bad thing to add in there. Then you go in and you create a method. So public string, let's learn Maven. That could be called anything. And this method is going to return a string that says, hello, Maven from Spring Boot. And then we'll throw a little get mapping annotation on there that says that'll respond to / hello Spring or hello Maven. I don't know, something like that. Now I can click Control-Shift-O or organize the imports here. The errors will go away because those are just references to annotations that I haven't imported yet. So organize imports and you see the imports appear. The errors go away. You do have to spell things properly. Your code has to compile. So that was a little error that I had right there. Just type it in too fast, but that's simple stuff. Oh, and there is one other thing. If you've got a Spring Boot application, the main method has to call the class itself through a Spring application.run method call. So you say app.class, pass in the args, and then you're ready to go. I could comment out this stuff if I wanted because it's not really necessary anymore. But and there you go. That's a Spring Boot application that will actually work as a RESTful web service. And in fact, when you build it, you can actually get Spring to build this and build an executable jar for you. So I'm going to actually just build this normally right now. I'm going to right click. I'm going to say run as a Maven install. This will just build the project normally, but it's not going to actually use any of the neat Spring Boot plugins that I've added to the POM file. And I just want to show you the size of the file that gets created normally. So over here in the Walmart folder, Target folder, the build is successful. I can look at the size of this jar file. The jar file is 2.93 kilobytes. So that's just basically, you know, the basic project that I've got here all packaged up in a jar file. Notice it's a zip editor there. Jar files are just zip files with a silly extension. That's all they are. But watch, that's going to grow when I say to Spring, don't just put all this code into a jar file, put it into an executable jar file that has Tomcat or Undertow packaged inside of it so that the jar file could run and run my web services. And to do that, it's a little bit of a different command. And I'm actually going to do this in the terminal window. And I'm just going to say Maven clean and package and call that Spring Boot plugin and specifically repackage the application that you build and put the jar file into a deployable folder in Tomcat and then package this all up in an executable jar file. And then you notice that file system is getting changed and updated. We've got a new jar file. If we look at properties, notice it's gone to 18 megs. That's because it's now got an application server that hosts Java applications built inside that jar file. And that jar file is executable. We can run that jar file at the command line. I'm actually just going to run it here inside of Eclipse. I'm going to run the Spring Boot application as an application just to prove to you that indeed we did create a Spring Boot application, a RESTful web application that responds to web-based requests. You see Spring Boot opening up there. It's starting on port 8080. The name of our method, of our resource, is Hello Maven. So I'm going to make sure we don't forget that. And I'm going to go to localhost 8080 Hello Maven. And boom, we get a response back. Hello Maven from Spring Boot. And there you go. We have just used Maven to configure a Java project to include all of the different jar files that would be required in order to support Spring Boot. And look at the effective POM there after we've added Spring Boot in. Holy smokes, that's impressive right there. That's an effective POM right there. And we've now, very quickly, I said 8:09 is 9 after the hour is what I said earlier. Now it's 8:14, so like 5 minutes, less than 5 minutes. We've created a Spring Boot application and created a RESTful web service. So all of that is pretty cool. Thanks for sticking along. If you're not a hardcore Java developer, I just wanted to show you how cool and easy that was. By the way, if you are interested in Spring and Spring Boot, check out my Spring Boot tutorials over on the server side and on YouTube. But there you go. That's how easy it is to work with Maven inside of Eclipse. I think the next thing I'm going to do is just show you a little bit of Jenkins, and then we'll wrap things up. But there you go. I hope you're enjoying this journey. So here's our last stop on our Maven journey, and it's taking a look at Jenkins. Now, if you're working with Maven, you're working with a build tool, you probably want a continuous integration tool as well. And that's what Jenkins is. It's a continuous integration, continuous deployment tool. So what is continuous integration? Well, the idea is if you're working on a team with 5 or 6 people, they're all committing to a Git repository constantly. And it just makes sense that somebody pulls the code out of there and compiles it and makes sure it works, right? Just because you can commit code to a Git repository doesn't mean that it works, right? I've committed plenty of code that doesn't work to Git repositories. So what Jenkins does is it will pull code from a Git repository and it will compile it and perform other functions on it too. Run, test, maybe package it, maybe push things to a remote repository or something. You're probably thinking, that sounds a lot like Maven. And it is. In fact, under the covers, Jenkins just uses Maven. And if you actually look at the logo for Jenkins, and Jenkins is a fork of Hudson, what are the names Hudson and Jenkins have in common? They're both names commonly used for butlers in movies and television programs. And the idea is a butler doesn't do anything, right? Like, despite what you may have learned from watching The Fresh Prince of Bel-Air and seeing Joffrey do some cooking or clean the house, butlers don't do cleaning. Butlers manage the housekeeping staff. Butlers don't cook. Butlers manage the chefs. Butlers don't do anything. And Jenkins doesn't do anything either. Jenkins just is an automation tool that delegates to other tools, be it Maven or Gradle or Docker or Git, to do all the heavy lifting for it, and it ends up taking all the credit. So watch this. I've got a GitHub repository right here, and this GitHub repository has a POM file in it. So it's a bunch of Java code that's written inside of a Maven project. Any GitHub repository, you can grab a link to that repository by clicking on that beautiful green button that says code and copying the GitHub URL. And I'm going to feed that GitHub URL to Jenkins. I'm going to create a new item in Jenkins. I'm going to call it the Maven Jenkins example. Not a creative name, but it will do. It'll be a general freestyle project. I'll click OK. When it starts up, it says right away, it says, well, where's all this code that you want to build going to come from? So I'll say, well, it comes from Git. Really GitHub, but Git is the tool that pulls it down. Again, Jenkins doing nothing. Jenkins just asking Git to pull some code down for it. But I paste my GitHub URL in there. When I click off and into something else, the error goes away. it asks for which branch. Be careful. Most repositories now use main. We're getting away from the master verbiage, but that branch is old, so it does have a main master branch on it. So it's going to pull from the master branch and do something with it. What's Jenkins going to do? Well, it's not going to do anything unless you add a build step. And the build step that I'm going to include is to invoke a top level Maven target. And which one am I going to do? Well, I'll do the install. You can do compile, test, package, whatever you want here. But I'm also going to say run FindBugs, run PMD, and run CheckStyle. And I don't think we did FindBugs earlier, but we did use the PMD and CheckStyle plugins earlier. We saw Maven running those. Those are Maven plugins. So that's your build step. And then you can have a post build step. And there's a post build step here to record compiler warnings and static analysis results. And FindBugs, PMD, and CheckStyle, they're all referred to as static analysis tools. So I'm going to click on that option as a post build step, and I'm going to ask it to, well, find the CheckStyle stuff and bring that in. I'm going to add another tool. I'm going to add PMD. So let's aggregate the PMD results. And what else did I mention? FindBugs as well. There's not going to be any bugs in my code. That's going to be a very lonely project. But that's it. I've just created a Jenkins job, and I'm doing continuous integration. So I'm continuously integrating code that gets checked into a Git repository by a team of 5 or 6 developers. Scrum says you should never have more than 10 developers on a team. There's the Git repository right there I'm going to pull code from. There's the command that I'm going to run, Maven install, FindBugs, PMD, CheckStyle. And when we're done, we're going to use a tool to aggregate all of the data that Maven generates for us. So I'm going to click apply, I'm going to click save, and then there's a beautiful build now button. I'm going to build now. That'll run this build. It's going to pull that code down from GitHub. It's going to run the Maven commands on it, aggregate everything together, and bring it back. And Jenkins is going to make it look like it did all the work, when in reality, it just delegated to Git, to Maven, to a bunch of Maven plugins, and pulled all the data together. Okay, so it's completed. I'm going to click on that number 1. It says that everything went well. I've got the green check mark. But look at this. No warning from FindBugs. I told you there'd be no warnings. There's 4 warnings from PMD. I'm a little nervous that it looks like the logo there has a gun on it. I'm going to click the PMD warnings here. It's going to go in here and say, hey, there's an unnecessary import. I'm like, no, there's not. There's no unnecessary imports in my code. Show that to me. So I click over here, and then finally it says, oh, it's in that score repository. And okay, maybe there is an unused import there. But the tools actually take me right to the code, right? Like you're actually seeing Jenkins finding the results of FindBugs, and now I could see the code, the error inside of Jenkins, which is actually pretty amazing when you think about it, right? And now developers have no excuse not for fixing their code, right? As soon as you check something into Git, Jenkins runs the static code analysis, and now you know if there's any bugs. And my CheckStyle has 195 warnings in it. I shouldn't take credit for this repository, but these are mostly style things, right? The braces are in the wrong spot. Although I do think like a hidden field check there is a little bit more serious. So you can go in and take a look and see if there's some code in there that's got a hidden field on it. And you can dig down in here and it says, oh, line 7. There you go. So that is Jenkins now integrating with Maven, and the two of these working together to create a continuous integration and continuous delivery pipeline. And they do say that the primary measure of success when you're working in Agile is the delivery of software to the client, and continuous integration tools like Jenkins make that happen. So it's a pretty cool and a pretty awesome tool. And that just about wraps things up here. I want to remind you, I'm the editor-in-chief over at theserverside.com. We got lots of great tutorials on Java, on Maven, on Jenkins, on Docker, on Scrum, on Agile. So if you're interested in any of those things, head over to the server side and check out all the content that we're generating over there. I think you'll really, really enjoy it. In terms of me, if you head over to Amazon, I got a couple of books out there. I wrote a book called Pickering of Springfield. It's all about the fact that Springfield in The Simpsons is actually based on a small town in Canada called Pickering, Ontario. So I highly recommend that. I also wrote a couple of books on Hibernate and Java. So Hibernate Made Easy, JPA Made Easy, check that out. And I've also been working with a young freelancer over on the server side as well, named Darcy DeClute. She's at Scrumptuous on Twitter. And she's published this really awesome Scrum Master certification guide. So if you know anybody that's into Scrum, anybody who wants to get Scrum Master certified, or anybody that just wants to learn more about Agile development, again, over on Amazon, I highly recommend that book as well. As far as me, if you want to learn about my personal antics, you can always follow me on Twitter at CameronMCNZ. And if you're watching this on YouTube, well, why don't you subscribe on YouTube?